Hi everyone, welcome back to Zero Analyst. This is the day 15 of our 30 days Python series. We have finally completed 2 weeks in this series, and today we will be talking about NumPy operations in Python. So today we will be learning about 1D array. What is array? First we will learn about what is array. Then we will see how to create 1D array, which is called one dimension array, how to create two dimension array, how to create three dimension array. Then you will be learning how to access elements from each of these arrays using indexing and slicing. And then we will see some of the operation that you can perform on NumPy, which is called mean, median and standard deviation. As well, at the end we will be doing one end-to-end project. We will be applying all of our learnings which we will be learning today. So let's start with the mini definitions about NumPy. Now if you see, NumPy is a powerful library for numerical computations in Python. So basically where you are doing core numerical operations in Python, you'll be using NumPy. It provides support for arrays. Now array, we will talk about what is array. It provides support for matrix. So if you do not know matrix, you can check. So we will talk about matrix as well in the futures. Then if you do any large collections of mathematical operations, then you would need NumPy. So if you want to learn more about NumPy, you can click on this link. That's going to take you to this official NumPy page where you can see this is the official NumPy documentations. Now you can learn each and everything about NumPy from this documentation itself. Now you see it's nice definitions where it says NumPy numerical Python. So pi means Python and num means number. So number and Python mix, they have created NumPy. So it's an open source Python library, is widely used for data engineering and data science project. So the first task is going to be, we need to import a NumPy in our Python, because NumPy is not inbuilt library. It is an additional library which you need to install first. So let's first see how to install NumPy. So let's first see how to install NumPy in your workspace. So first we need to go to our workspace, which is here, and let's open a terminal. So here I would just need to install NumPy. So let's see how to install NumPy. So you can simply type pip show. It should give you if you already have NumPy installed. If you have already installed, so you don't have to install it. So if you just run it, you just need to say pip show NumPy, and you should be able to see. You see NumPy is not available in my computer, but if you want to see everything, so pip, we can say pip list. So this is going to give us the packages that we have already. So it seems I don't have NumPy. So I do have matplot, inline, mysql connectors. Okay, no problem. So let's go ahead and install NumPy. So to install NumPy, you just need to say pip install NumPy. It should be installing NumPy within a second. You can see NumPy has installed successfully. So now let's go ahead and import NumPy into this script so that we can use NumPy. So as we have already installed NumPy, we can just go ahead and add a cell here. So let's go ahead and add a cell, and we need to say import NumPy as np. Okay, so that we can use this short alias. Okay, so this is the alias I'm giving. You can simply import this way NumPy, but this is the best practice. So once you execute it, you can see NumPy is imported. We can verify the version. So for that, you can just say np dot underscore version, small letters, underscore. You can see the version is a 2.11. That means it's verified that our import is done. Now let's go ahead and see what is array, and because we will be creating different arrays, and in NumPy you will work with arrays. Now arrays are same as like list in you have learned in Python. So if I talk about list, I can just create a list something like this, right? 1, 2, 3. So inside this square brackets, you can give multiple different values. So these are a list, right? If you want to check this data types, I can just go ahead and say something called type of this. You can see it's showing as a list because you have this data which is separated by comma inside this square brackets, right? This is how you have the list. Now this is the list. Same way you will be working in a list in NumPy, it's called array. Okay, so now way we understand this array, we will see, and now we will also see what is the difference between list and array. So why we will use array, why not list, why we are going to use NumPy. Okay, so let's go ahead and understand this with an example. So here I have some example. Now in array you will have different options like 1D array, 2D array, which you don't have in list. So in list you would just have your data like this. Inside this square brackets you would have the data simple like this. Okay, so you can only have one data. So let's say 2, 3, let's say 0, let's say 4. Okay, so you can have different values which is inside this kind of square bracket. So this is your list, right? This is your list. When you talk about array, so in array you have kind of the same way. If you see in array you would have the data stored in different cells. In one cell you would have each numbers. Now here you have 7, here you have 2, here you have 9, here you have 10. So this is called 1D array. Now let's see the definition. It says in computer programming, an array is a structure for storing and retrieving data. That means you can store the data in different cell, and you can retrieve and use it later on whenever you will need it. Okay, so now you have seen what is 1D array. You will have the data something like this, simply small, let's say a box like this. So this is your 1D array. Okay. When you talk about 2D array, so 2D array you would have something like this. So this is your 2D array. So you would have basically 1D like this and another D like this. Okay, you can have even more as well. Okay, that is still going to consider as a 2D. So this is your 1D array. You can see this is a 1D array. In 1D array you can have basically kind of two lists. So where you have like one list earlier, where you have this is the one list. In 2D array you can have one more list after this. Okay, so maybe something like maybe 4, 5, 6, 7. Okay, different values. Now they must be store another big list. Okay, something like this. So this is called 2D array. Let's create some array and let's see what are the operations you can perform, and then we would see how to create 2D array. So let's first create 1D array, then we would see 2D array. Now the reason why we use this array and why we use a Numpy, because Numpy is especially built for working with numbers. So let's see, Numpy means it's called NUM, right? Num means number and Py means Python. So Numpy was specially created only for Python to work with the special numbers. That means where you have to work with the numbers for any scientific project or any data engineering project where you only have numbers, that's where you will use Numpy. So let's first understand with some example. Let's say I am going to create a list, so the same list which I have created here. Okay, so this same data I am going to use. Now the way to create a Numpy, you just need to say something like this. Okay, NP, because this NP means Numpy, which you have given here, short alias. You just need to say array, and this array takes a list. Okay, same way, this way. So we will give our list. Now this is an array. This time it's not a list anymore. This is an array. If you want to check, I can just give a name called maybe ARR, and I can check the type, right? I can say type of ARR, and you can see it's saying numpy dot nd array. So nd means dimension array. So this is how you create array. Okay, now even if you want to see how many elements you have this array, which is ARR, you see ARR has these values, right? If you want to see how many elements, 1, 2, 3, right? So you can just type size. Okay, the size is going to return the number of elements that you have in your array. Okay, you can see we have 3 elements. Now we can see what is the dimension. Okay, so for that you just need to type ndim. Okay, ndim is going to tell the dimension. At the moment it is 1. We would create 2 dimension to see how this function works, so that is fine. So you have next, which is called shape. Now shape is going to return the value as a tuple. So you would have the dimension first, then you would have basically the elements. Okay, at the moment we don't have the dimension because it's only one dimension. That's the reason you don't see it here, but we would see that. Okay, now we can do some operations here. Let's say we can find the standard deviations. We can find this these 3 elements, the mean or median, all those things we can find. Let's see how we can find mean of this ARR array. Okay, so you can just type np dot mean. Okay, and inside this parenthesis you just need to give your, which is called array, and you can see this mean is 2. Okay, if you want to kind of print the nice results, so just print it. You can see mean is 2 at the moment, which is, this is the middle, right? It's 2 data is already organized. Let's add some more data. Let's say I'm going to add something called maybe 0, maybe 5, maybe 6. Okay, some more elements. I missed 1 comma. Okay, now let's see what is going to be the mean. That's the mean. You can see we have got the mean as 2.83. Now we can find the standard deviation as well, and we can find this median as well. So you can just say median. It's going to give you the median, which is 2.5. If you want standard deviations, you just need to say std, and you can see standard deviations 2.1. Okay, for this series. So this is how you create 1D array in Numpy. Let's go ahead and now learn about second D array. Okay, now for the second D array, you need to ensure that you have kind of 1D, which is this, and 1D, which is this. So that means you would have 2 lists. Okay, this is one list, this is the second list. They both must have the same number of elements, otherwise you will be getting error. So, and they both must store inside outer list. Okay, something like this. So let's go ahead and create one. So numpy, which is np, and array, to create an array. Inside this I would just need to put this square brackets. So this is my 1D array, right? So I would just organize it this time. This time I would organize it something like this way. Okay, so basically this is my 1D array. Even if I don't have the elements, Still this is a 1D array. If you want to check, let's go ahead and kind of give a name to this, which is called maybe x. Okay, so I would just go ahead and say x dot enddim, x dot enddim, which tell the dimension. You see it's showing one dimension, right? At the moment we have one dimension. Now inside it I would just need to have two more lists, okay, separated by comma. Okay, now there would be a 2D array. You can see it's now as a 2D array, because inside a whole list I have kind of two another list, right? So this is my 1D array, this is my itself, it's a 1D array, itself it's a 1D array, and they are separated by comma, they are stored in another 1D array. Okay, so this is your second array, you can say 2D array. Now if you can store some values to show you, just I can just store some values 2 and maybe 3, and here I can store maybe kind of 4 and kind of 5. Okay, so this is your second D array. So I'm just going to give a nice name called ARR2D. Okay, let's go ahead and say that instead of x replace with ARR2D. So it's now showing as a 2D array. Now let's see some operation that we can perform. So let's say I'm going to find out, let's say, the shape. Okay, so I would say that, which is called ARR2D, and here I'm going to say shape, that's going to return a tuple. So you can see 2 and 2. Okay, so that means 2 dimension and 2 elements. I can add one more elements here, maybe 4, and here I can just add 6. Okay, so let's take the shape now. If you see, the first one is the dimension. So we have 2 dimension. This is the first dimension. Inside it I have another dimension. This is the reason it is a 2 dimension, and each dimension have 3 elements, because you cannot have, like in one dimension you cannot have more elements. So you will be getting error. You can see it's not allowing you, because you can only have the same number of elements in each of this dimension. Okay, so that's fine, and this is how you can see the shape. If you want to see the size, it's going to give you 6, because we have 6 elements. Okay, so that's one of the thing. Now if you want to find the mean or median, you can just use the same function, which is called np dot mean. So put your array name, which is called this, and you see the mean is 4. If you want to see the median, so you can just change this to maybe standard deviation. If you want to see the standard deviations, it's kind of 1.29. If you want median, so it's going to be median of 1.29, which is 4. If you just put more 3, here also 3, maybe here also 3, now you will see median is going to be 3. Okay, so we have seen the operations how we can perform in a second D array. Now let's see something called slicing and index. Okay, then we would see third D array, slicing and indexing. So let's see our first array, which is called the first array, that was ARR. So let's see the array again, ARR. You can see this first array have all this element, right, which is called 0, 6, 5, 1, 2, 3. Okay, now first is sorting function that we can perform in array. So let's go ahead and say sorting. If you want to sort this, it's going to be same as like you use median, mode, or mean. So same way, so we can just go ahead and say np dot sort. It takes the array name, so we would just keep our 1D array. You can see it is now sorted 0, 1, 2, 3, 4, 5, 6, right? Now the values are sorted. What if in case you want to access from this, you want to access these elements, okay, or maybe these 2 elements? So for that you can use simple indexing. So it's going to be 0, then it's going to be 1, then it's going to be 2, right? So 0, 1, 2. So you can just say 2 here, and you would have, which is 2. Let's print the result. So we can go ahead and say print this. You can see the result is 2. Okay, so let's print the array again, ARR. Okay, so we have the value which is unsorted. Let's first sort it. So to sort it, you just need to say np dot sort. Inside it you put your array, which is called array. Let's save it as called array underscore sorted. Okay, now this sorted array we can use and we can access the elements. Okay, let's go ahead and say that this time I want only this 6. First I want this 6, then I would want 5 and 6. Okay, so let's see. First let's see how we can access this 6 using negative index. So I have this, which is called array sorted, is my variable name, and if in case I want to access the last element, that's going to be -1, right? You can see it's 6. I have the result. So everything you just need to print it to see the nice result, which is 6. Okay, what if I just need only kind of this last 5? What if I need this sorted array from this sorted array, let's say I need this 5 and 6, right? So I can use a negative indexing or positive indexing, which we have covered in the D2 of this Python series. So I can go ahead and see what I need from this is array sorted and use a slicing. So slicing works fine in Numpy as well. Okay, for 1D it is the same as like you do with the list or kind of the normal Python functions. So same as like 1D, but when we talk about like 2D, we will see it's going to be a little different. Okay, so here I would just define that I would start with -2 and end with the n element. So -2 and then colon nothing, right? Because I need till the end. So I can use, that's the negative indexing. If I need the positive indexing and I want this 5 and 6, so I would just go and say 0 1 2 3 4. So this is going to be my 4, right? So it start from 4, then it's going to be 0 1 2 3 4, 0 1 2 3 4 5. Okay, so 5 plus 1 I need to give again. If you just skip it, you get this 5 and 6. Okay, but if you want to give the last element, that's going to be 0 1 2 3 4 5. 5 plus 1 6, so you need to say 5 plus 1 and you get the same result. You can see 5 and 6, which is part of slice of your this array. Okay, so this is how you can use array on a 1D. Okay, and this is how you sort 1D, and this is how you access one of the elements from 1D. Now let's see how we can do all these things in a 2D array, which we have already created 2D array, which is here. So let's see the 2D array. So array.2D is our 2D array. So that has kind of, the first I have, which is called 2 3 3, and the second I have 4 5 3. Okay, so let's give some maybe different numbers so that it's going to be more better. So 2 3 4, I would just give it 4, and I would just keep call 6 7 8. Okay, now let's print it again. So we have kind of this values is 2 3 in one of the elements, and in the second elements we have 6 7 8, right? What if I want to access this first element, or maybe this 4? Okay, so this 4 elements I want to access from this array 2D. So how do you access? Now it's not 1D, right? You cannot just say that this and give me 0 and maybe 1 and maybe 2. So that's not going to work, because this array is a 2 dimension. So first you need to access the first element, then inside the first element you can access this. Okay, so the way you understand it here, if you have a 2D array, so first you need to tell which element you want to touch. So you want to touch this element, you want to touch, or this element. Okay, if you want to touch this element, so you would just say this element was going to be what? This is going to be 1, this is going to be 0, right? Now inside it, then you can just define what you want. So same way, what you would do is that you would say that 2D array of 0. So that means I want from this 2D array, I want this first element. And if you see, now I have 1D array, because this result itself is a 1D array, which is inside this list, right? 2 3 4. Even if you want to check this dimension, so you can just say ndim. So you would see the dimension is going to be kind of ndim, ndim. Dimension is, you can see it's 1D. Why? Because this result that you see, it's a 1 dimension, right? Inside it, if you see, this is your 1 dimension, this is your 1 dimension. If you want to understand it here, so this is your 1 dimension, this is your 1 dimension. They both are stored in another dimension. That's the reason it's a 2D array. Okay, now when you have the data in 1 dimension, I can store it in one more something called x. And if you want to access this 4 from x, you can just say x of basically, which is called -1, or maybe you can say 2, right? You get this 4. Okay, that's one way. Second way is that same thing, without saving it, you can just add one more square here, and here you want to access from this first element, because you're already inside this first element of this array 2D, and then you would just want to access this. You can use a -1. Okay, or you can just use 0 1 2. So that's from both way you can get the same result, which is 4. You can see we are getting the result as 4. If you want clear output, then you just need to put this inside a print statement, and you would have the clear output, which is 4. Okay, now let's see how to access a slice. Let's say this time I want to access this slice, which is 7 and 8, but that is from my second elements of a 2D array. So array name is this, right? So this is our 2D array. Here this time I want to access these two together, so it's going to be a slice. Earlier it was an index, right? Earlier only access one elements. To access two elements, so you can just say array 2D. First of all, you would need to go to this element, right? You would need to first go to this element. So that's going to be, this is the first element 0. This is your second element, which is 1. Or this, they are part of this 1D, right? So you would say 1, and you would see the second element, which is 6 7 8, right? Now from this you need to access maybe this 7 and 8. If you need only this 8, then you can simply go ahead and say that what you need is basically -1, right? You get the 8. But if you need 7 and 8, then you have two options. You can start with the negative indexing, that's going to be -1, -2. So you can say starting from -2, and I don't need anything at the ending, so I need everything till the end. So 7 and 8, that's one way. Second, you can say 0 1. So 0 1 starting from 1 and goes till the end. So you can say starting from 1 goes till the end, you will still get the same thing. Okay, so these are the two way you can get slice from a 2D array. I have shown you how to get it from 1D array. If you want to sort both the array, so it's already sorted, but if in case our data is not sorted, we can kind of see how we can sort it. Okay, so to sort it, you just need to, let's go ahead and unorganize in our here. So I'm going to add something called 5. Here I'm just going to add 0, and here I'm going to add 4. Here I'm going to add 2. Here I'm going to add maybe 7, 9. Here I'm going to add maybe kind of 6. Okay, so let's say now we want to sort this data. So at the moment we have this array 2D. Oops, let's give it current name array 2D. So at the moment we have 5 4, and first elements I have 504, and the second I have 296. Okay, so let's go ahead and let's see how we can sort it. So you can say numpy, which is numpy dot sort, and inside it you can just give your array. Oops, array. Okay, and you can just run it. You see the first element is being sorted, which is 0 4 5. Second element is being sorted, which is called 2 6 9. Okay, so this is how you sort the data. Okay, now I know this may be a little confusing at the starting, but once you practice, it's going to be really easy. So what you just need to remember is that if it is a 1D, it has to be just inside one list. Okay, but if it's a 2D, so in one list you would have like another list, something like this. Okay, another list, and something like this. Okay, so each list would separated by comma. So that means this is an individual one list, this is an individual one list. You can say this individual 1D array, this is individual 1D array. So this is now a 2D. What if in case you need a kind of 3D? So if you need 3D, so inside it again you would have an individual 2D individual 1D array. So you can say here you want 1D, and you can have one more 1D here. So here you can have one more 1D, comma, and one more 1D. Okay, so this is going to be your 3D array. So what is actually happening here is that each side you have, which is called 2 elements. Okay, so if you want to kind of see it, we can go ahead and store it in maybe called array 3D, and I would just need to say numpy dot array. Inside this parenthesis I just need to put it. Okay, so let's go ahead and kind of put it inside the parenthesis. Let's organize our query. Okay, so this is our 3D array. Okay, so the way you see it is that you see this is your main array. Inside this main array you have kind of this which is called 1D array. So 2 1D array. Inside this you have basically again 1D array. So this is 1D array. Inside it I have one more 1D array. Now if in case I want to see the dimension, so I would say nd.third.ndim. Okay, you see now it's showing 3 dimension. Now let's put some values. Let's say I say 1 2 3. Let's say here I would just going to put kind of 3 4 6. So here I'm going to put maybe 4 5 6. Here I'm going to put maybe 5 6 7 or 8. Okay, we have the values. Let's go ahead and print it. So array 3D. Okay, now I can see this is a 3D array. So what you have here is that first you have this starting from here to here, it's your 1D array. Then here to here, it's your another array inside 1D array, and same as like here to here. Okay, and they individually have 1D array. Okay, so this is how working. So the way you count how many dimension arrays are there, you can count just this square brackets. You can see it has a 3 square bracket, that means it's a 3D array. Now you can create as many as array you want. So you can say np dot array, and you just need to define it this way. So if it's a 1D array, it will have something like this. Okay, if you have a kind of inside it, you can just define it. Let's say you want 3 elements. Okay, let's make it this time 3 elements. So let's go ahead and see I have 3 elements. Okay, now this is still kind of 2D array, because inside 1D array I have individual 1D array. Okay, if I want to show you, so let's kind of say between x, and let's say I'm just going to say x dot enddim, you can see it is still 2D array, because still they are kind of 1D array which is inside another 1D array. But if I now insert more inside them, then it's going to convert as like 3D array. Let's do that. So let's first organize it properly. Okay, now here I'm going to add another 3 elements. So that's going to be something like this: 1 2 3. Okay, so each of these 3 elements would have the same number of elements, right? So now even if it is empty, still you can see that this is going to create your this dimension. This is going to create an array, and you would be able to see the dimension. Now if you see, this time it is 3D array. If you want to make it 4D, then you just need to go one more D. Then we would have inside each of this, we would again have kind of another number of elements. Okay, inside this as well. So that is where it is going to convert into 4D array. So that may get a little confusing, but the way you understand is that if you see 1 2 3, if you read till here, that means you get the element, right? Till the time you reach element, that's the number of dimension you have it here. Now there are some functions to practice it. You can just say np dot zeros, and you can define the shape. Let's say we want something like 5. You can say that it has created 5 1D array with 5 elements, which is 0 0 0. Okay, now we can say something else which is called np dot ones. So this is going to create an array with the kind of, you can say, 1 elements. Okay, I mean the elements which is with using 1. You can define how many numbers you want. Let's say I need 10, so it's going to create 1D array with 10 of 1. So you can see. Okay, now let's see how to access from a 3D array, how to access the elements. Okay, now let's say I want to access this 8. Okay, so let's say I want to access this 8 first, then I'm going to access maybe this 4 and 6, let's say, or maybe this 5 and 6. Let's see how we can access it. So let's go to the basics. It's going to be same. If you want to access in this kind of 3D array, if you want to see it here, so we have the 3D array here, right? So if you want to access the first, it has kind of elements which is called, this element itself, it's kind of 1 element, and this is your second elements, right? So first, if you need this 8, this is going to be 0, this is going to be 1. Okay, now first you would access 1. Inside 1, again it has 2 elements, 0 and 1, correct? Then you would just go 1, and then you would get 8. Okay, so the way you can say something like this. Okay, if you say you want kind of 1, you get the second elements. So now it's a 2D array. You can see that enddim, it's a 2D array. Okay, now from this 1, what you need is this 8. So you need to go to the second element. This is the first element, this is going to be the second element. So the second element is going to be 0 and 1, right? That's going to be 1. So you get the second element. Now it's a 1dim array. So you can just say enddim. You would see it showing as a 1 dimension. Okay, so here you need what? Here you need this 8. So this time this 8 is going to be what? 0 1 2. You can use 2, or you can use -1. So that is how you get these elements. If you want to see nice results, so just put it inside the print, and you would have this result, which is 8, correct? So you have seen how to get this. So first we need to consider this element. So this whole elements, it's 1 dimension, and this whole elements is another elements of this, the outer elements, right? Then inside it I have kind of 2 another elements. So from that I would first need to access the second elements, then I need to access this using -1 or simply 2. Okay, so let's say this time we want to access this 5 and 6. Okay, let's see how we can access this 5 and 6. So for that I am just going to say that, which is called array.3d. Now from here, first of all, let's see that if it is a part of the first or if it's a part of the second elements. Okay, now if you just say 0, you get, which is this portion, right? This is your first element. Okay, you see 2 square, 2 is square, that's it's and starting here, it's ending here. That means this 5 and 6 is part of your second element, which is going to be 1. So let's say 1. Yes, it is a second elements. Now out of seconds, it's a 2 dimensions, right? And if you check, it's a 2 dimension, which you have earlier checked. Now what I want here is that this 5 and 6, so that's going to be part of this first element. Okay, it again has 1 and 2 elements, so we would access this 0 elements. That's how I get 5 and 6. Now if you check enddim, it's going to be again 1 dimensions. So here you can just slice this part which is called 5 and 6. So you can use kind of -2 dash column, and that's how you get the 5 and 6. If you want positive indexing, so you can say which is called 1, and you get 5 and 6 starting from 1 ending with nothing. Okay, so you have seen how to slice from a 3D dimensions, and how to slice from 2D dimension, how to slice from 1D dimensions. Okay, so these are the functions that we can perform. We have also seen mean, median, and standard deviation. Now let's learn how to reshape NumPy array. So let's go ahead and say that we have an array called ARR, and inside it let's store some values. Okay, so I would say 1, 2, maybe 3, 4, 5, 6. Okay, so I have this 6 elements in an array which is called ARR, and let me just create an array. So np dot array, and inside this parenthesis I need to put this, right? So this is my 1D array. If you want to check, I would say array dot ndim. Now this is a 1D array, you can see it here, right? Now let's see how we can reshape this. So for that we just need to say array dot reshape, and you can just give it which is called, maybe we want 3 elements together, so 3 and 3. So you just need to 3 and 2. So we want 2 dimension. You can see now I have a 2 dimension. So 1 square 2 square, that means it's a 2 dimension. So inside 1 dimension I have this, and this, right? Different elements. Now let's see how we can change this to 3 dimension. Okay, to change it to 3 dimension you just need to say array dot reshape, and you would need to just define it something called 2 layers and 3 rows and 1 column. Okay, now if you see our data has a 3 dimensions. So I have the main which is called 1D, which is this main dimensions, which is 1D array. Inside 1D array I have kind of this another array which is this one. Okay, and which is a 2D array, 2 dimension array. So I have one more 2 dimension array. Inside it I have kind of 1 elements 1D array, 1D array, 1D array. Okay, so you need to make sure that you have this sufficient elements, then only it's going to work here, because here I have changed this to 2. That means it's a 2 layer. This is the first layer and this is the second layer, but I have kind of 3 elements. That means in each of this layer I would have 3 elements. Okay, you see here I have 3 elements, and this 1 means how many columns it's going to have, because it's because of I have only 6 elements, so it's going to only have 1 columns. So 1 1 1 1, it's 1 column only. Okay, so this is how you kind of reshape any array. Let's go ahead and check the dimensions. You can say ndim. You will see the dimension is now showing as a 3. Alright, now let's see our last topic, which is going to be concatenations of 2 array. So let's go ahead and first create another array which is called array1, and inside it I'm just going to create simple array called np dot ones, which will have 1 values up to kind of 5 elements. Okay, if you want to print it ar1, you can see it has 5 1. Okay, so let's go ahead and create one more that's going to have zeros, but again 5. Okay, so this one is going to be 2. Now let's go ahead and concate this 2. So you can simply type np dot concate, and inside it you just need to give your both the array. So you can just keep both the array inside another parenthesis. So array1 comma array2. Okay, so this is how you can see our the element is concatenated. I can just give a name called array con. Okay, if you want to see this array size, so you can just say size. You can see 10 elements it's have, because this has 5 elements, this has 5 elements. Okay, this is how you concate 2 arrays. Okay, now let's go ahead and do one project which is going to be end of today, and let's see the project. Okay, so let's read about the project. It says temperature data analysis. Generate a random temperature data for 30 days and calculate the mean, median, and standard deviations of the temperature over the month. Also find the days with temperature above the average. Okay, so for that first we need to create a data. Now using NumPy you can create a data using the random functions. So let's go ahead and first create a data of last 30 days. Okay, so we can go ahead and say np dot random, and you can say dot to find out uniform. Okay, uniform rand. So this uniform is going to take low high options, and also going to take a size. Based on that it's going to create a data set. So you can see uniform, and low what I want is maybe something called 25 or maybe 22, and the high it's going to high, let's give it something called maybe 38. Okay, and size I want for 30 days. Okay, so this is going to create a data set. I'm just going to call it weather. Okay, so let's go ahead and execute it. Very simple function. It's kind of going to create a data set. If you want to see this, it's a one dimension data set it has created, and you can see all the numbers are between what range I have given. Okay, now let's go ahead and see what are the things we need. So we need to find out mean, median, and standard deviation. So let's start with mean. First of all, let's write out what you need is mean. So I'm just going to say that whether np dot mean, I just need to give my weather, which is called weather, and I can save this in maybe variable called maybe weather mean. Okay, so let's print this results, which is called print. You can see the mean is 30. Let's find out the median. Okay, for the median I would just say median is going to be simple, np dot median, and I would just need to say median variable. Let's print the results, so it's going to give us the median, which is 29. Okay, so 29 is the median. Let's go ahead and see what else we need. So next we need is the standard deviations. So for the standard deviations I would just need to change this np dot std, and here I'm just going to give it call weather of std. Okay, let's print this results. Let's change this to std. Okay, standard deviation seems to be 4.5. Now let's see the last statement of the problem. It says find the days with the temperature above the average. Okay, so the average is the mean, right? So the mean is going to be, which is 30.0, right? So we need to filter this all these elements by this 30.0. So for that it's very easy. We can use this name, and you just need to go ahead and say that what you need is the weather data of this. Inside it just type weather again, and we would only need the data where this weather is greater than this mean. And so let's kind of go ahead and execute it. You will see the days where it's greater than mean, which is all those days are, you can see, greater than mean because the mean is 30. Okay, so this is how we have filtered the data. You can just save it, call maybe hot days. Okay, so let's print the results. Alright, so you can see the results. We can see it here. That's it for this video, guys. Thank you so much for watching the video till the end. If you have enjoyed this video, do like the video and share your thought in the comment box. And if you have not subscribed to my YouTube channel, do subscribe to my YouTube channel. Have a good day. Take care. Bye bye.